Welcome to Zigmatech Consult Limited. This is a learning hub, so I'll be taking you through chemistry. Our topic today is carbon and its compound. The things we are going to look at for specifically, one is we will define allotropes of carbon after definition of carbon. Then we name two crystalline allotropes of carbon. Then state two difference between the two allotropes of carbon. Then the number two is name four products of destructive distillation of coal. Then number three, we'll be talking about notes on the preparation or uses of coke, number one, charcoal, number two, lampblack, number three, and finally, animal charcoal. Finally, we will look at notes on the preparation and uses of producer gas and water gas. Listening. So, before we start, I would like to define carbon. Carbon is a non-metal in group 4 of the periodic table. It occurs naturally as diamond and graphite. Then it also occurs in impure form like coal, in the combined state as petroleum, wood, and natural gases. All these ones I have mentioned outside diamond and graphite are the one we call the amorphous carbon, or you call them non-crystalline because they are non-crystalline in nature. The structure of carbon. Carbon exists in network crystals. If you look at the diamond, it has octahedral. So this network crystal, they exist with the atoms of crystal held together with covalent bond. Why? Because carbon is a non-metallic element. Carbon being a non-metallic element cannot undergo ionic bonding or electrovalent bonding, but it can only undergo what we call covalent bonding. And for the fact it undergo what we call covalent bonding, carbon is a non-metallic element. Then again, carbon exists with oxidation number of +2 and +4 in each compound. That is why you have carbon 2, the one we call carbon monoxide, and we have carbon 4, the one we call carbon dioxide. Allotropes of carbon, as we have mentioned earlier, the three allotropes of carbon that are specified here is diamond, graphite, and amorphous carbon. Diamond is alone on its nature, then graphite is on its own. Then the diamond and graphite is the one we call the crystalline form of what? Carbon. Well, amorphous, inside amorphous you have wood charcoal, you have animal charcoal, you have coal, you have coke, and other ones you have there. And these ones we call the amorphous. Another name for it is called what? It's called non-crystalline form of carbon. Now let me talk about allotropes. Allotropes is the ability of elements to exist in various forms in the same physical state. You have carbon there, and it started existing in different forms. The first form is in form of diamond, then carbon can equally exist in form of graphite or any of these ones I mentioned under amorphous, which I say they are non-crystalline in nature. Diamond to start with. Diamond is the purest form of natural occurring carbon. It is found as a colorless, lustrous solid which can transform into brilliant gems. What is colorless? Colorless is something that does not have color. If you see any transparent glass, you can see through. I'm not talking about translucent. Translucent, you see partially, but transparent glass, you see everything the way they appear. That is how diamond is. Then two, they are lustrous in a way that they shine. When you see them, they glitter, they shine, light pass through them. And what exactly, immediately you point light through them, then they will definitely shine. Then diamond is solid. Remember, we said that diamond is the hardest substance known on planet Earth for now. There's no other substance that's harder than diamond in planet Earth. Then two, the diamond crystal is octahedral. Octahedral means it has 8 shape. Octa means a shape. In mathematics, octagon is a shape that has 8 sides. Then it is a giant molecule in which the carbon atoms are closely packed and held by strong covalent point. Then students always argue this point. If diamond is the hardest substance known on planet Earth, why is it that it's not a metallic substance? It's not a metallic substance because it does not possess the charges of metallic elements. So diamond is is held together by strong covalent bonds. Remember, there is weak covalent bonds, then we have strong ones. So diamond exists with strong covalent bonds. This is the structure of diamond on the screen. If you look at it, you count a complete set, you will see that it make up the A side that we say that is octahedral. Because of the A side in this structure, in each joining together to give you this giant structure of diamond, we say that diamond has a shape, octahedral shape. Don't forget, we call it octahedral because it has 8 sides. Properties of diamond. What are the things that make diamond what it is? Number one, it is the hardest substance known. I have said that before now. Then if you bring diamond, diamond can use as precision instrument used in breaking other materials like iron, steel, because it's the hardest substance. Then it has a higher melting point. Before you melt diamond, you go higher in temperature than the temperature that can melt iron in blast furnace. Then number three, it is very, very dense. In chemistry, when we say something is dense, means the thing is very heavy. Heavier means dense, but that's scientific language in chemistry. When we refer to something that's heavy, we say that is what? Dense. Then number four is that it is resistant to higher temperature and chemical attack. Because it is the hardest substance, it has a higher resistivity. It does not allow chemical to definitely attack it or weigh it down easily. So it can be used in most of the supporting instruments in higher equipment like a machine used in manufacturing industry. Finally, it is a non-conductor of electricity. Despite how hard it is, knowing that it exists with covalent bond, which is the bond of non-metallic elements, definitely it does not conduct electricity because it has no free valence electron. There's no mobility electron that can do the conduction of electricity. Uses of diamond. What are the things we can use diamond to do? Being very hard and dense, diamond can be used in the industry in drilling for mining. When you are mining from the ground, under the sea, or beneath the rock, you need a hard substance. So diamond is used in producing such equipment, knowing that the equipment will be able to pierce through the rock, which is very, very hard. Number two, they are used as abrasive to sharpen very hard tools. They are there to sharpen other tools. When we talk about something that's being used in sharpening other tools, you use something that is stronger in order to sharpen the other one. If it is not so, definitely diamond would have been eaten up whenever you're using it to sharpen other tools. So diamond is the hardest substance, so it can be used as abrasives. Number three, they are used for cutting glass and metals. You use them in cutting glass and metal, precisely those hardened ones that cannot be cut by iron. So diamond can be used in cutting glass and metals. Then they are used as pivot support in precision instrument. When we talk about pivot support, is that you have a pivot here, then you have another thing you fix in between. As they move around, they're supposed to have eaten up this, but because it's diamond that being used as the pivot support, it remains the same from year to year. It does not worn out easily. That's what we mean by pivot support. Then five, they are used as dies for drawing wires. When we see the electrical company like most of the companies that electrify house and other things, they make use of this to draw wires through the pipe. And the pipe wiring, it does not see any wire on the building, but you see that there is light in the socket. It moves through a pipe inside the block wall before you now get them out. If you use something that is less in hardness, definitely such will break. But if it's diamond, diamond can withstand pressure and even weight. Then finally, they are used as valuable jewelries because it is higher refractive index and dispersion power. Because diamond has this higher refractive index, it's used as jewelries. Whenever you see some women wear their necklace, you see a pendant somewhere, and that pendant will be glittering. From year to year, it does not tarnish, neither do you see it going low in quality. It remains the same. So diamond is a precious material. We go into graphite. After diamond is graphite. Graphite occurs naturally as plumbago. It occurs naturally as plumbago. An opaque black solid. As you can see from the screen, that's a sample of a graphite, and this picture is very clear. If you see graphite in its raw form, this is how it appears. It maintains the black color of carbon. Remember that carbon has a black color. That is why in a exhaust pipe of our cars generator, you put on there, you get carbon in a little form, in form of soot, precisely. But the soot is part of the non-crystalline. That is why it does not have any crystal. When you touch them, you does not feel any crystalline structure on the touching. Then this is the structure of graphite. Now look at it very well. You see the place where you have, in graphite, you see the place where you have carbon atom. The round shape in this diagram is the carbon itself, and carbon has the ability to bond with other elements, and that is why in this case we say that carbon is catenated in nature. Then in between the two circles bond here, then you see a broken line from this diagram, and that broken line represents the van der Waals forces, and the van der Waals forces produce this bond you see here. What is van der Waals force? Van der Waals force is the weak force of attraction that exists between the molecules of non-metallic elements. So after having carbon is bond with the other one, then graphite is soft in nature. That is why it exists with this van der Waals bonds. Then as we discuss further, I will tell you more things concerning graphite different from carbon. There's a very huge discrepancy between these two crystalline allotropes of carbon. Properties and structures of graphite. Number one, the properties. Graphite is an opaque black crystalline solid with a metallic luster. When we say that it's opaque, opaque means something that cannot allow light to pass through it. If you point touch on me now, you cannot get the light you cannot get the light reflected behind me. But if it's a glass, you can get the light through the other side. Now to continue, we say that it's black in nature. Yes, graphite is black in nature. From the previous slide, you see that the raw form of graphite is black in nature. Then another thing is that it's metallic luster. It's not a metallic element, but it has the attribute of what? Metallic element, because it conducts electricity and it shines whenever you use it in producing a material. Then graphite, it is soft and flex easily because of its layer crystal structure. Now, if you look at the structure, you go back to the structure, you understand that there's a broken line that represents the van der Waals forces. And because of the van der Waals force in between the two carbon bonds, you discover that they slide over each other and it has a higher melting point, despite that it has van der Waals forces in between the particles itself. Then it is less dense than diamond. It is lighter than diamond. Example of where you can see graphite is in mixing it with lead to produce pencil. Pencil is not heavy. That's to tell you that it's less dense, it's less heavier than diamond. Then it is relatively chemically inert. When we talk about inert, it means something noble. It cannot be easily attacked by chemical. That is why in electrolysis in chemistry, we use graphite as one of the noble electrode, which we call inert electrode. It cannot contribute, it does not dissolve to add to the concentration of the electrolyte inside a battery or any of these rechargeable cell. Then it is a good conductor of electricity. That is the only thing that differentiates it from diamond that's very huge as a non-metallic material. It's an allotrope of carbon, one of the allotropes of carbon, but carbon is a non-metallic material, but graphite has the ability to conduct electricity because of the presence of mobile electron in the crystal lattice. Remember, carbon bond with another element, but in between the two bonds of graphite, you see the van der Waals force that make it to have a mobile electron in the crystal lattice, and that is age that the graphite has above carbon when it comes in terms of conduction of electricity. So it's a good conductor of electricity. Uses of graphite. Graphite is an excellent dry lubricant because it's dry in form, so we can use that as dry lubricant. Remember that other lubricants comes in oil form like grease, and after a while they worn out, you have to put. But if you use graphite, it's a dry lubricant. It makes anything you're using it for to be clean and dry, because each layer structures allow one layer to slide over another. If it's something that has a crystal that cannot allow each other to slide over one another, it cannot be used as a lubricant. It would have been causing what we call cracking. Number 2, it is used as lubricant in engines where higher temperature melts ordinary lubricant. In this case, if you use grease, higher temperature will melt them, they will run out. Within a space of 30 minutes or 1 hour, you discover that the engine does not have anything to lubricate it. But if you use graphite, temperature does not bring it down, because the melting point of graphite is higher than all these oils. So because of that, it is non-volatile and non-sticky. It does not stick to anything or accumulate one side and allow the engine to suffer. Then number 3, a mixture of graphite and clay is used as lead in pencil. That is how we have our pencil today. It's mixture of graphite and lead that give you the interior of the pencil. Then it is used as electrode in electroplating and in dry cell, because it is a good conductor of electricity, number 1, and relatively inert. When we say relatively inert, it conducts electricity, does not dissolve in that electrolyte. So if you're doing electroplating of gold or silver or platinum, it does not contribute. It will allow gold to move to the cathode and electroplate that particular chamber. But if it's other metals like copper will contribute and dissolve, and the concentration of that electrolyte will have more copper therein, which is not ideal. Means if you're electroplating with gold, you see yourself electroplating together with gold and copper at the same time. So graphite solves the problem of not dissolving. That's why we call it a night electrode. Then another thing we want to talk about here is it is used to line crucibles for marking higher grade steels and other alloy, because it can withstand higher temperature. Let me tell you, if you use marker or anything and write on a particular surface, if you expose it to sun, as time goes on, the color will fade. That is why you see signposts on the road, sun will be coming on them and rest of them. After a while, the signpost, the color will fade. They say it's no longer new again. But in this case of graphite does not fade with temperature, because it will stand a higher temperature. That is why we give it the attribute in the properties as something that has a higher melting point. So heat of the sun does not affect it easily. That is why it's being used in marking in crucible. Knowing that crucibles are laboratory apparatus we use in heating substances in the lab. So if you use something that's affected by heat, definitely you know that heat will wipe out the calibration mark. You may not be able to read accurately. You get confused, and by so doing, experimental error will occur. Finally, it is used as black pigments in paint. So when you use it as black pigment in paint, it sticks and make the paint to last longer. This attribute can enable you to differentiate between an original paint and a paint that is not too concentrated in its color formulation. The difference between diamond and graphite. We will start with their nature. If you look at this picture, you see that diamond is black and opaque. It does not allow light to pass through, but diamond is transparent and it can allow light to pass through. The next one is amorphous carbon. After we have treated diamond and graphite as the crystalline form of carbon, allotropes of carbon, then amorphous carbon is another one that joins it. Remember that amorphous carbon is a non-crystalline allotropes of carbon. To start with, amorphous carbon is not considered as true allotropes of carbon, because the carbon atom consists of mini crystals of graphite bound together by impurities. Because of that impurities, we call them amorphous, and they are not as strong as diamond and graphite, which is in the form of crystals. Then, with the exception of coal, which is mined from natural deposit, this one occur naturally. Others can be prepared in various ways, as I'm going to outline then. Number 1, coal. When you look at this place, you see this coal in a raw form. Coal is a rocky fire that comes from vegetation, or you can get them from the farm. And when you move around, like in Enugu, you can get coal. If you look at it from this picture, it seems as if it's a lump of gravels or lumps of refuse dump that are being kept together, they decay and they form a sticky block material. So coal is different from other ones, and we have destructive distillation of coal to give you other products. So this one is an exceptional product from other ones that are not true allotropes of carbon, but they are still amorphous carbon. Coke. Coke is non-volatile residue left behind after destructive distillation of coal. These are one of the products we see when we have destructive distillation of coal. Number one, it contains about 95% carbon and burns smoothly without smoke. If it burns smoothly without smoke, means that undergo a complete combustion. A complete combustion produces carbon 4 oxide, while incomplete combustion produces carbon monoxide. That is why a new generator or a new car that the engine is working perfectly does not produce smoke because it's undergoing a complete combustion. But though a new car or a new generator can produce smoke if the fuel is bad, and if the fuel is bad means that you have to check the octane rating and solution to it can be reforming. So in this case, for this coke to be produced and without smoke coming out, definitely it is a product of what? Complete combustion. Then coke used mainly as fuel. You can use them as fuel in as much as they undergo complete combustion. Now look at the example of coke here. It looks like charcoal, but it's not really charcoal. They have similarity, but charcoal is softer and lighter. Coke is harder. They look exactly like charcoal. Like if somebody brings charcoal to you, you may think it's cool till when you touch it. Charcoal, you can compress it. Charcoal, you can crush it easily, but this one you cannot crush easily. That is why if you see that finger they are holding that hammer, it is an iron that we use in hitting it hard before you crush it. But what they are doing here is what we call local manufacturing. In a local manufacturing, you can crack it this. But this day, we have sophisticated machines and every other thing that can crush this easily in a modern method where you can have turn-ups in many jerrycans or as the quantity you want. Carbon black. We often call it black soot. It's not black soot. Either you call it carbon black or you call it soot. These are finely divided carbon particles produced by burning carbonaceous materials in a limited supply of air. If we burn them in a limited supply of air, like a exhaust pipe of a car or a exhaust pipe of any engine, you see that the engine is a mock-up, closed, and combustion is taking place there. And after the combustion, the waste product is being released through the exhaust pipe. So if you happen to have something like that, then the product that will come out from the exhaust pipe will be soot. No matter how new a car is, after some months or some weeks, put your finger into the exhaust pipe or use something that is white, put inside the exhaust pipe and clean it, you see that black things comes out, and that is what we call soot. And soot is dangerous to human health because it can combine with hemoglobin in the body system and cause fluctuation in breathing and blood flow. Then charcoal is common in our environment, but we have 3 types of charcoal. Charcoal can be made by heating wood, nut shells, bone, sugar, and blood. Number 1 is wood charcoal. Number 2 is sugar charcoal. Then finally we have animal charcoal. So we are going to discuss them one after another. This is charcoal, a typical example of a burning charcoal. If you move around our environment, you see people using this type of charcoal to roast like corn, roast other things. And this type of charcoal you see here is the one common in our environment. We call it wood charcoal. Then combustion of carbon allotropes. Number 1, allotropes of carbon burns in plentiful supply of air to produce carbon 4 oxide. From the equation, you can see carbon solid. The S you see in bracket is solid. Then the G you see in bracket of oxygen is gas. So solid is reacting with what? Gas. We call it combustion to produce carbon 4 oxide. And this carbon 4 oxide is a product of complete combustion. So this is a typical example of a balanced equation of a complete combustion of carbon. Then charcoal fire is there. Charcoal is used in making fires. In many countries like Nigeria, we use it to roasting corn here, roast plantain, and roast other things by the roadside to make business. So we'll be going to the summary of this lesson by giving you the meaning of carbon again. Carbon is a non-metallic in group 4 of the periodic table. It occurs naturally as diamond and graphite, and another aspect of it is the amorphous carbon, which occurs as an impure form of coal. And in the combined state, you can have it as petroleum, you can have them as wood that produce charcoal, and you can have them as natural gases. Thank you for listening. We are going to practical questions, and the practical question we'll be gotten from Examguide app. And your Examguide app is an app that contains JAMB question, it contains SSCE question, it contains junior examination question by NECO, BESE. And if you go through this app, you will see that this topic we are treating here is in line with examination questions. Like all your WIRE questions are there, NECO questions are there, JAMB questions are there. So let's give a trial to 1 or 2 questions based on the topic we have treated. You will enjoy it. Now let me take you through. You click on this place, like I want to write JAMB question now. I click on JAMB. After clicking JAMB, you see many subjects here. And all these subjects you have here, you can choose more than 1 or 2. But because we just finished studying chemistry now, let me use only chemistry as example. Then when you come to this place, you select the year you want. If you want 2010, you pick 2010. But here I want to select at random so that I will have all the question that is pertinent to carbon and its compound. After that, you check the number of questions you are looking for. Then here I want to put 50 so that I will get a wider range of what I'm looking for. After that, you select topic. Look at the cursor here, you click on topics. Then the topics will now show. If you look at it, all the topics are marked. And because they are marked, you go to all and click. Once you click all of them become unmarked. Then you start scrolling looking for carbon and its compound as the topic we studied now. If you come to this place, I have carbon and its compound here. Sorry, then it moves. It is your duty to check. Immediately you click, you know whether it is still there or the thing moves to another place. So getting to this place, I believe I have carbon and its compound here. Then I click on carbon and its compound. Click inside this white box, it tick it good. Then you come to allotropes of carbon, you click it. Then once you click it, you come into the box and tick it. Then you start scrolling because I'm trying to tick the ones that pertain to the topic we just did now. Then after that, I talk about carbon and its compound. Properties of carbon is part of what we did. Then let me just select only 3. Then you click inside this place. After that, you click OK. Once you click OK, you will discover that you have to get started. Then you click here. Once you click get started, the number of questions that is attributed to the topic you are studying will display for you. Now we have 7 questions to answer. I have number 1 question. Number 1 question says, diamond is a hard substance because its carbon atoms are held by dash. Number 1, the localized electron. It is not the answer. Van der Waals forces, no. Van der Waals forces in graphite. Then strong dielectric covalent bond. Yes, that is the answer because the diamond is held by strong derivative covalent bond. It's just strong covalent bond. Remember, it's covalent bond, but it's a strong one that's holding this one. So that is how you can select your question. Now, answer number 1. Let me take you through number 2. Number 2 say carbon is tetravalent because. What is the reason for that? 1, it said electrons in all the orbitals of carbon are equivalent. No. All the atomic orbitals of carbon hybridize. No. The 2s and 2p atomic orbitals hybridize. Then finally they say the electron in both 2s and 2p orbitals are what? Equivalent. Yes, because of that, you see that this is the reason why carbon is what? Tetravalent in nature. Remember that tetra means 4. Tetravalent means that it has 4 electrons at the atomos shell. That is why carbon belongs to group 4. The number of electrons at the atomos shell determines the group in which carbon belongs. Then finally, I want to take you through question 7 that say diamond is used in making jewelries due to its what? Give us reason. Is it because it's transparent? A. Is it because it has higher melting point? This reason cannot be enough. Is it because it is the hardest substance? Must we use hard thing to make jewelries? No, but because it has higher refractive index. It can glitter and make the jewelries you're wearing or whatever you're wearing beautiful and attractive to people that's looking at it. On this, we end this lesson. I urge you to use this exam app regularly. The more you use it, the more you get familiar how to answer questions, and you get familiar with topics in chemistry and other subjects as well. And it will enable you to have a wide horizon when we talk about examination. Many students are intelligent, but they may not be able to pass exam except they get acquainted with examination pattern. So that's what we are going to take for now. That's the only thing we take for now. I will still meet you again in subsequent lessons. Thank you.